Hello and welcome. Today's project was supposed to be something completely different, just like last time. But there are some minor complications again. So today's topic will be a spectrum analyzer, also known as color music. A spectrum analyzer is an instrument that presents an electrical signal within a specific frequency domain, which is very confused with an oscilloscope. It breaks down the composite signals into individual frequencies and shows how strong these frequencies are. To build our spectrum analyzer, we need only three basic components. A microphone, because we decompose the sound and have to capture it somehow. Then the main heart of the project is the Arduino, a development board to which all the necessary components, LED strips, which represent the individual signals, are connected. But to understand the full principle, we have to delve deeper into the deeps. So let's start with perhaps the most basic and the most necessary chapter, and that is sound. Sound is a mechanical wave that propagates through the environment. It is an analog signal because its properties, such as amplitude and frequency, change continuously over time. Sound has many properties, but at this moment it is enough for us to know the meaning of frequency and intensity of sound. The frequency of a sound is the number of waves, or periods, produced in 1 second, and the intensity of the sound, which indicates how loud the sound is. Since computers can only work with numbers, we have to convert our signal to digital. In this case, we have to sample it, according to the sampling theorem, which states that the sampling frequency must be at least twice the maximum frequency that occurs in the signal. But how do we achieve signal decomposition? The answer is very simple, and that is the fast Fourier transform. The fast Fourier transform is a mathematical tool that converts a time signal into a frequency domain. But if I were to explain its principle exactly, I would first have to explain the discrete Fourier transform, and that would be too long. So we will explain the fast Fourier transform on a simple example, namely mixing colors. Imagine that we have two colors, yellow and blue. We mix these two colors and we get a green color, but we stop liking it after a while, and we would like blue and yellow back. This is exactly the problem that fast Fourier transform solves. Fast Fourier transform would take our green color and break it down into its basic parts, blue and yellow. Unfortunately, I don't have any serious video from a fully assembled project, so I'm going to play a video from an unfinished project.
Takhle nám to tady pachá. Máchary tu přijdu.